the physical properties of the nitro compounds. In this, I'm gonna talk about the physical state, or let us say how these molecules actually appear to our naked eyes. After that, we will also talk about the solubility of the nitro compounds, followed by the density as well as the boiling points of these nitro molecules. And in the end, we will also be dealing with the thermal stability of these nitro compounds, the thermal stability. So let's get started. As you can see here, the first physical property is the physical state. By physical state, we mean what type of appearance, what type of color, and what type of smell any particular chemical compound is having. So we know that the general structure of a nitro compound is RNO2, and depending upon what type of R group is present here, we can classify the nitro compounds into two categories. The first one is when this R group is something aliphatic, like you can see here in the molecule of nitromethane. We used to call such nitro compounds as the aliphatic type of nitro compounds. On the other hand, we do have a possibility that this same R group can be like this type of aromatic group here, or let us say this type of aromatic R group. So in that case, we used to call such kind of nitro compounds as the aromatic type of nitro compounds. And here you can see I have taken two examples for such compounds. The first one is the nitrobenzene and the second one is the 1,3-dinitrobenzene. So now let us talk about the appearance, color, as well as the smell of the nitromethane, nitrobenzene, and the 1,3-dinitrobenzene. And it will give us some insight about the physical state, that is the first physical property of the nitro compounds. So it is very clear from here that the appearance of the nitromethane is what it is having. It appears that it is having a liquid type of state. On the other hand, if you look to my right hand side, the nitrobenzene is liquid. On the other hand, the 1,3-dinitrobenzene is having a solid type of state. So we can write here that regarding the appearance of the nitro compounds, on one side where the aliphatic are liquid in nature, the aromatic type of nitro compounds are either liquids or solids in nature. Now the color for the aliphatic type of nitro compound, we can write here. You can see here in this bottle, the nitromethane is what it is, colorless, so better to write it like this. On the other hand, the aromatic type of nitro compounds are having yellow to pale yellow type of color. And in the end, the smell of the aliphatic type of nitro compounds is like something pleasant type of smell. On the other hand, the aromatic type of nitro compounds are having distinct type of smells. So this is all about the physical state, the very first physical property of the nitro compounds. And now let us move to the second physical property, which is what it is, the density of the nitro compounds. So you can see here a beaker which is full of water, and if I will be adding a drop of some nitro compound with the help of some dropper, it is not going to float over the surface of water like this. Instead, it will go deep down and will settle at the bottom of this beaker, clearly indicating that the nitro compounds are actually having higher densities as compared to that of the water. The nitro compounds have higher densities as compared to that of water, as compared to that of water. So this is all about the density part. Okay, now the next thing is the solubility of these nitro compounds. In chemistry, like dissolves like. This means a polar compound is soluble in a polar type of medium. On the other hand, a non-polar type of compound is soluble in a non-polar type of medium. So now if we want to talk about the solubility of a nitro compound in water, we can see here that this nitro compound is what it is having two poles, one negative and one positive. So better to call this nitro compound as a polar type of molecule. In the same way, although not having a full positive and a negative charge, the water molecule is having a partial negative charge on the oxygen atom and a partial positive charge on the hydrogen atom, but still the molecule of water is also polar in nature. So it seems that the nitro compounds being polar will be easily soluble in water because that is also polar in nature. But let me tell you one thing, it also depends upon what type of R group is present in the nitro compounds, because the nitro compound is not just this fragment here. It have to contain some organic part here like this, and depending upon what type of R group is present here, it will be affecting the solubility of that particular nitro compound in water. So let me start from here. Let us take the simplest case when this R group is a single carbon atom organic group. So one carbon atom, and this is attached to the nitro part here. So let me complete the valency of this carbon atom. So I have to attach 3 hydrogen atoms here. So increasing the size of this R group, let us now go to a organic group in which 2 carbon atoms are present. It is our same nitro group here. And now I have to place 5 hydrogen atoms here like this. And moving further and further increasing the size of the R group from 2 carbon atom to 3 carbon atom, I can show it like this. Here is my nitro. The first hydrogen atom, the second one here, third one, fourth, fifth, sixth and seventh. So now if you compare these 3 nitro compounds, in the first case, this is our R group here attached to the nitro part. And in the second molecule, this is the R group here. And here is the third R group in the third molecule of nitro compound. So we can see here that as the size of the R group is increasing here from 1 carbon atom to 2 carbon atom, and then in this case 3 carbon atoms, and moreover the fact that the carbon and the hydrogens are having same electronegativity, and thus whatever R group we are having here, it is nothing, it is actually non-polar type of group in nature. So as we are moving from here to here, and because the size of the R group is increasing, which is actually non-polar in nature, thus we can easily say the solubility of the nitro compound will be going to decrease as the size of the R group will be increasing from here to here and then from here to here. So it not only depends upon the nitro group, it do depend upon the what type of R group is attached to the nitro part. And because R group is non-polar in nature, so whenever the size of this non-polar R group will be increasing, the solubility will decrease in case of water. Now this was the story of the aliphatic type of nitro compound. Once again, by aliphatic we mean when the R group is something aliphatic in nature. And now let us see what will happen if we are having aromatic type of R group here. So let me take the simplest case, the case of the benzene ring, which contain 6 carbon atoms like this. And here is my nitro group here, the 3 double bonds. And let me complete the hydrogen atoms here, the first one, the second one, third one here, fourth, and in the last, the fifth one. Once again, because the R part here, the R group here is made up of only the carbon and the hydrogen atoms, this large R group here is actually non-polar in nature. So it is that much big that this polar nitro group is very small as compared to this non-polar R group here. So this is the reason why the aromatic nitro compounds are not at all soluble in water. So in the end, we can say the aliphatic type of nitro compounds are soluble in water, but to a lesser extent, and that do depend upon the size of the R group. If the size of the R group is increasing, the solubility will tend to decrease. On the other hand, if we are having aromatic type of R group, in case of a nitro compound, it will be totally insoluble in water. And now let us talk about the boiling point of the nitro compounds. So in this general structure of the nitro compound, you can see this nitrogen is having a positive charge and the oxygen atom is having a negative charge, such that we can see the nitro compound in the form of this dipole here. And here is the second molecule of the nitro compound. It can also be imagined in the form of a dipole, something like this. And definitely there will be a sort of interaction in between the negative end of this dipole and the positive end of this dipole. And let me show it like this. In the same way, there will also be attractive force in between this positive end of this dipole and the negative end of this dipole here. So now the thing is, if I used to represent this first molecule here like this red dot here, and the second one once again with this red dot, there is actually present a very strong force of interaction in between the two nitro molecules because they are having high dipole moments. And this force here is nothing, it is known as the dipole type of interaction. The dipole type of interaction. So you can see here, this is a beaker full of some nitro compound shown by the red dots here. And now it is very clear that in between each dot here, there is present what? There is present a strong intermolecular force of attraction, and that is nothing but a dipole type of interaction. Now what if I want to separate these molecules far apart from each other such that I have this type of scenario? The first molecule here, and here is the second one, here is the third one, such that they are far apart from each other and they are just escaping from this beaker like this. In order to have such a scenario, what is required is I used to break this dipole interaction in between these two nitro compounds. So what will happen is, when it was present in this beaker in the liquid form, and when I will break somehow the force of interaction in between these nitro compound, what I will have is the nitro compound in the vapor form. And in order to have such kind of transformation, what I need to have is I need to supply some energy in the form of heat here. and this is nothing, this is known as the boiling point, or the boiling in case of any nitro compound, that the molecules are made far apart from each other such that they are no longer having the interactive forces in between them. And as they are far apart from each other, so definitely it is now not in the liquid form but is present in the vapor form here. So now we can say, in order to break these strong attractive forces here, a lot amount of energy is required. And that is very clear from this table here. If we take a nitro compound, say this one, the nitromethane, and some hydrocarbon of comparable molecular weight, you can see here the molecular weights are quite close. You can very well see the difference in their boiling point, where the nitro compound is showing a boiling point of 374 Kelvin. The corresponding hydrocarbon having comparable molecular weight has just a boiling point of 138 Kelvin. The reason being, in case of hydrocarbons, the dipole moment is not there. On the other hand, the nitro compounds are having high dipole moments, thereby exhibiting the dipole-dipole type of interactions in between their molecules. In the second example, you can see here, I have compared a molecule of nitroethane with a molecule of N-pentane because they are having comparable molecular masses. And you can very well see the difference here in between their boiling points, where the hydrocarbon part is having just 143 Kelvin of boiling point. The nitroethane is showing a boiling point as high as 388 Kelvin, and once again it is only because the nitro compounds are having high dipole moments. So in conclusion, we can say, as compared to the hydrocarbons, the nitro compounds always have high boiling points because they are having high dipole moments. And this is only because of the dipole-dipole type of interactions which exist in between their molecules. Okay, in the last, so now let us talk about the thermal stability of these molecules. On your screen, you can see here it is a polynitro compound. By poly means multiple nitro groups are present, like at position 2 here, then position 4 here, and position 6 here. This part is what it is, the toluene part. So we can call it as a 2,4,6 trinitro toluene. And we can also call it by a shorter name, that is the TNT, or the trinitro toluene. Now if we start heating the TNT molecule to very high temperatures, it has been seen that it will undergo some sort of decomposition, resulting in the formation of a molecule of nitrogen gas, a carbon dioxide molecule, and water is released in this reaction. Now what happens is, this reaction starting from here to here is a very, very fast type of reaction. Two reasons are there for this. The first one is, if you look here onto these products, this nitrogen atom and this nitrogen, they are having a triple bond. A triple bond is a very, very strong type of covalent bond. So the nitrogen molecule is actually a very inert type of molecule. So starting from this side, because we are going like this, resulting in the formation of something very, very inert molecule, this reaction is extremely fast in nature. And moreover, the second driving force which is making this reaction so fast is what? That not only energetically favorable, this reaction is also entropically favorable. The reason being, it is resulting in the formation of two products molecule which are actually gases. So this reaction from here to here is energetically favorable, as well as it is entropically favorable also. But one thing you should not forget is that this is only true as far as some polynitro compound is concerned. It is not true at all for every nitro compound. And one more thing I want to add here is this reaction is explosively fast in nature, that when I used to treat the TNT molecule with high temperatures, in explosive amount of energy is released in such reactions. So this is all about the physical properties of the nitro compounds, and keep watching my videos. Thank you.